In this video, we will work on some problems of USEMO and work on 4 background ideas. I leave 7 homeworks. If you want to learn 40, 50 important ideas and formulas in geometry, combinatorics, algebra, and number theory, feel free to send message to my WhatsApp number in the description and comments. Okay, we will consider small examples. It's so much important also in USEMO problems, in IMO problems. Then the next idea is when you want to find minimum or maximum of something, you should consider answer is between 2 cases. Like this, idea 2. Idea 3, we consider groups. Considering groups is so much important. And in also some problems of IMO. And idea 4 was when, for example, we want to find number of elements in arithmetic progression. We will solve this problem. And I will leave 7 homeworks. Homework 1 is for this problem and n is odd. Try to find the answer. It's similar to even. Homework 2, this use some more problem. Homework 3, if you want to solve more homeworks or want to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. If you want to prepare for BMO, British Mathematical Olympiad, USEMO, or any other math exams, we can work on the background ideas. And if you want to do that, as I said, send message to my WhatsApp number in the description and comments. Okay. Okay, let's solve problem 1. A stick is defined as a 1 by k or k by 1 rectangle for any integer k greater than or equal 1. We wish to partition the cells of a 2022 by 2022 chessboard into m non-overlapping sticks such that any 2 of these m sticks share at most 1 unit of perimeter. Determine the smallest m for which this is possible. For solving these types of problem, I can say the most important idea to solve, for example, USEMO problem, AMC, AME, especially USEMO full solutions exam, or BMO, for example, British Mathematical Olympiad is, or IMO, International Mathematical Olympiad considering small examples. Okay, so here, for example, let's consider 2022. It is our n. Okay, so first try n1. The answer is what? For n1, obviously the answer is 1. Okay. For n2, the answer is what? It can be this. You cannot place 2 by 2s. So we can place at least at most 1 by 2 and 2 1 by 1. So it cannot be less than that. Because if you want to have less than that, it will be like this or vertically. So the answer is 3. Now for N3, try to find a good example and also try to prove the answer is not greater than that. Try first on your own. Okay, let's check 3 together. If we consider 3, okay, then we can show like this, like this, like this, like this. Let's only find an example. It's not important the example is best example or not. For example, we can place 1 by 3 here, then 1 by 2 here, then this one, then 1 by 2. It satisfies. So here, in these types of problem, second idea. When you want to find minimum or maximum of something, try to create an interval. Okay, for example, sometimes someone when I was a student, I tried to find an example, okay? For example, try to find an answer. It is, for example, try to find the answer is 4 or 5 or something like that. But if you work like this, and one part always, for example, is with example, one part with proof, this part, or vice versa, then, for example, you reach here 5, you reach here 10, then sometimes this part, example, helps you to understand the answer, sometimes proof. And then, for example, in some problems you reach 5 and 6. So if the answer is 5, you get this mark of this part. If the answer is 6, you get mark of this part. So try to find any two number for these places. It is not important that it is the best answer or not. And then try to reach one number. So here we proved answer is at least or at most what? 1, 2, 3, 4, 5. 5 was possible. The problem says find minimum. Okay. Here it says the smallest. So when 5 was possible, the answer for this case is 5 or smaller than that. Now try to see can you prove, for example, it is at least what? Try first on your own. See can you prove it is at least 5? Try. Okay, so here let me tell you something. When we select these, we are ignoring, for example, these sides. Let me explain. Consider, for example, this tile crosses how many edges? This edge, this edge. And then this tile, this edge, this tile, this edge. So our tiles pass through these edges. If all tiles be 1 to 1, then we have 9 tiles. Then for each green side, we consider green sides the sides that the tiles passes through them. So you say, okay, 1, 2, 3, 4, -4, because when it passes through one of them, it means instead of 2, 1 by 1, we use 1 by 1, 1 by 2. Again, when it passes through this, instead of, for example, this and this, we use one tile. Okay, so each green side subtracted number of tiles by 1. So 1, 2, 3, 4. It is 5. So now we want to see number of tiles is 5. We want to see that how many green sides are there. And so number of tiles will be what? Will be 5 here for 3 squared 9 minus number of green sides. Okay, so let's see how many green sides do we have at first. Let me draw a 3 by 3. Okay, so look, if you have this 3 by 3, we cannot have this. If you have this green side, we cannot have this green side that they have intersection. Why? Because when we have this, we have a tile like this. When we have this, we have a tile like this. Or look, we have a tile like this, maybe like this, maybe like this. It's not important. So, for example, we have this style or this style. When we have this one, we have this style or this style. So it means that this cell will be filled by one horizontal tile and one vertical tile. So we understand that our green sides cannot be like this, okay? Now let's check this one. Also, we cannot have like this. Why? Because, for example, we have this style or this style. And here, because of this, we have this style or this style. And as you can see, if you consider any of the cases, they have at least 2 common edges. What the problem says, they can have at most what? At most 1 unit of perimeter, okay? So we cannot also have this one. So we understand that our green edges don't have any intersection, okay? Now by this part, try to prove number of, if we want to prove answer is at least 5, okay? So when we want to consider smallest number of tiles, so we should calculate maximum number of green sides. So try to prove number of green sides is at most 4 in this figure. Try first on your own. Okay, let me tell you the proof. For proving this, we consider groups. Okay, idea 1 was this, idea 2 was answer, idea 3 consider groups. Also in IMO, this idea useful. Consider groups for pigeonhole principles. Look, if we consider these edges as 1, okay, all of them 1. Then, for example, these edges as 2, 2, 2. These edges as 3. These edges as 4. As you can see, we can select at most 1, and we've considered all edges. We consider each, we can select at most 1 because they have all of them have intersection in this point. At most 1 2, at most 1 3, at most 1 4. So we proved that n of green lines is at most 4. So we proved it when it is at most 4. So this one is at least 5. So we prove it is at least 5. So for n of 3, the answer is 5. Okay. Now let's check one more example and then try to generalize it. For n4, draw a 4 by 4. Okay, like previous one here, let's consider, as I said, sometimes this part helps you, sometimes this part. And look here, in all of them, here is with example, here is with proof. Because it is the smallest. If it was maximum, here was with example, here with proof. Okay, it depends if it is the smallest or largest, and also depends on the problem. Here, again, we say, okay, let's consider this point and the edges here. Then this point and these edges, this point and these edges, this point, this point, this point, this point, this point, and we've selected all of them. So we know that number of tiles equal to number of, let's consider these things here, blue edges here, we call it blue edges. 4 squared minus number of blue edges. Okay, 16 minus number of blue edges. So when we want to minimize this, we should maximize number of blue edges. So we've covered all of them. Why we've covered these edges? Because here with this one, here with this one. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So it is at most 8. So this one is at least, this one is at most 8. So at least negative of that, at least negative 8. So it is at least 8. Now let's find an example with 8 tiles. Try to find an example with 8 tiles first on your own. Okay, so let's consider, for example, 1 by 4, then 1 by 3, then this one, for example, this 3, 1 by 3, then this one. Oh no, this one is not okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It was an example with 9. So let's see, can we find a better example? Here we can have this and we can consider this. Will it be okay? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here we prove answer is at least 8 and at most 8. Okay, so the answer for 4 is 8. Now let's try to find a way to prove. As you can see here, we've selected 1, 2, 3, 4. And here we've selected these things. So, for example, for general and let's see, we should select how many points and then the answer is what? Okay, so look, because we have to select these edges, we should select one for each of them, okay, because of these edges. So here we should select all these things. So this is a large table. I've copied and pasted this to check, for example, general if n will be what. So we should select all these points, okay? This one, 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 this one. So now in general, how many points have been selected? Let's calculate. Look, if the size is n, 1 to n, then we have n minus 1 like this, okay? So it will be 4 times n minus 1 minus 4 because we've calculated corners twice, okay? In next step, so we've selected all these things. Now only this table is left. Let me show you this table, okay? We've selected all edges outside this table. And now, okay, so let's select this one, then we cover these two things, then we select this one, and this one, this one, this one, this one, this one. Okay, this one, this, 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 this one, this one, this. It is a 16 by 16 table, and because we've selected here and here, it is related that it is even. So let's consider when n is even. Okay, so here we've selected how many points. If we consider, we should see how many edges are there here. We have n minus 4, then we divide it by 2. It will be number of these. Look, for example, 16 minus 4, 12. 12 divided by 2, 6. 1, 2, 3, 4, 5, 6. Number of points will be this plus 1. Okay, and we multiply it by 4, and then we subtract it by 4. Okay. Now we've covered all these things, but here we should select this one because of these things. We should select this one because of these. Then in next step we select these things. Okay. So like this one, this one, this one, this one, this one, this. Okay, next step it is what? As you can see, it will be 4 times. And at the end we will check it for with n4, okay? See it's correct or not. Here it is n minus because look, it is this part. If I want to show, it is this part. So it will be 4 times n minus 6 over 2 plus 1 minus 4. Okay. So in next step, we should select these points. Okay, we continue and continue. Like this, as you can see, we are covering all edges. This one, let's see for 4 also, we did this. We said yes here, but we've not selected the last part. Okay, so let's continue. This part, this part, this part, this part, this one, and next step it is what? 1 to 4 times n minus 8 over 2 plus 1 minus 4. And this one is what? Again, this part, this part, this one. Okay, let's continue. And in next step, we should select this one, this one, this one, this one, and this one. And then at the end, we will select this one, this one, this one, this one. Okay, as you can see, and here we have to select this. I'm thinking that why? Uh-huh. Okay, so here we've selected the center, right? So it is 4 times n minus, for example, 10 over 2 plus 1 minus 4, up to last one. These numbers one by one, 4 times last point, n minus n over 2 plus 1. Let's check minus 4. Okay, so let's add all these things. Okay, look here. The previous of these is what? Is 4 times n minus 1 over 2 plus 1 minus 4, okay? And here we can say what? It is for what? If we calculate, it is n minus, on n minus even numbers, let's consider. Even number is n minus 2, okay? So it will be what? It will be 1 plus 1, 2, 2 times 4, 8. 8 minus 4 is what? Is 4. Okay, so it is 4. As you can see, this one, 1, 2, 3, 4, 5, 6, 7, 8. It is 8, and so on. So, but the last one is 1, not 0. Okay, so we should add by 1 here. It is 1, but the next is 4. Next one is 8. We continue. Up to last one is 4n minus 4 minus 4 minus 8. Okay, so it will be 1 plus 4 plus 8 plus 16 to 4n minus 8. Okay, when n is even. And it will be what? It is sum of multiples of 4 is 1 plus 4 times 1 plus 2, 2n minus 2. So it will be 1 plus 4 times n minus 2 times n minus 1 over 2. So it will be 2 times n minus 2 times n minus 1 plus 1. And it will be 2n squared minus n minus 2n minus 3n minus 6n plus 2. 2 times 2, 4 plus 1, 5. Okay? Now we've proved the answer for n is when n is even is 2n squared minus 6n plus 5. But as you can see here, because we had a center, so this one doesn't work for 4 because it is a small. These things will cover these. But we should check for n6. Okay, let's check for n6. Okay, if we had a mistake for n6, we will understand. Okay, let's check. Okay, so let's consider here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so in first part, let's see. 4 times 5, 20 minus 4, 16. Yes, in this case, 16. Now, here, we can select these things. Let's check. We can select these things, or and then we have to select this. Or we can select what? We can select these points. And now let's see. Did we cover? No. Yes. We've covered all these things here. We've covered, and we don't need to select this. So let's do something. Here we will understand in next level we should select that point. So let's correct them. Okay. So here we prefer to select these things. Okay, this one, this one, this one, this one, this one, this, this, this one, this one, this one. this one, this one, this one, this one, this one. Here, this, and this. Okay, so if we check, it is what? 4 times n minus 4, n minus what? No, n minus 6. 4 times n minus 6 over 2 plus 1 minus. Okay, now in next step, let me select with green. Here we've covered all things around that, so these points are left. Here we should select this one, this, this, and here we shouldn't subtract 4 because we've not calculated anything more than once, because here look, it is 4 times n minus 6 over 2 plus 1. Why we multiply by 4? Because we have 4 sides. Why we say n minus 6 over 2 plus 1? That is 3. So we subtract 6 from n minus 6 divided by 2 plus 1. Because we should consider also n points. Next one will be what? N minus 8. 4 times n minus 8. So let's correct this formula. We should subtract all these 4s. We should erase all of them like this. And let's continue. It is what? Here, this one is 4n minus 8. This one is 4 divided by 2. It's 2n minus 12 plus 2. It's minus 10. Okay? It is n minus 8. It is 2n minus 16 plus 2. It's minus 14. Okay? Now, let's consider what happens in last step. So, if we draw, so here, let's see. What can we say? We non-select this. We select this one, this one. Sorry. Here we should select this. Okay, that's the reason we don't calculate anything twice. This one, this one, this one, this one, this one, this. Then in next step, we calculate these points. Okay, and like this, and then we calculate these things. We calculate this. Okay, we calculate these things. Let's see at the end what happens. So by these things, it's 20 minus 14 minus 4 minus 4 up to, let's see, at the end it will be what? Here you select this. Okay. Another one, next step. You select what here? You select this one, 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 this one. Okay. So as you can see, here we select this one, this one, this one, this one. Okay. At the end, it will be 4. Because n is even, it is multiple of 4. And all of them are 4k plus 2. So you go up to, let's see, last one is 4. 4 times 1. So 2n, what happens here? 2n minus 10. So let's see, here it is 4. Okay. Here it will be what? It is 8. Okay. And all of them are multiple of 4. So what's the problem here? 2n minus 12. Oh, sorry, minus 12 plus 4. Minus 12 plus 4 is minus 8. And that's the reason considering small examples so much useful. Here it's 2n minus 8, then it is minus 4 minus 16 plus 4 minus 12. Okay. Now, for example, this one will be what? If we write these numbers, it will be n minus 10, n minus 12. So it will be 2n minus 16. Here is minus 24 plus 4, 2n minus 20, up to 4. Okay, so we should add all these numbers. It will be what? Let me calculate this part again. It will be 4 plus 8 plus, here, last one is 8. Last one is 4 plus 2n minus 8. And this one 4n minus 8. Okay, plus 4n minus 8. So it will be what? Here you factor from 4. We can factor from 4. It will be 1 plus 2 to 2n minus 8 over 4. Or n minus. We can do this idea, or let me tell you something else. We can say first one, use the formula of arithmetic progression. First one plus last one, 4 plus 2n minus 8 times number of them, which is last one minus first one over common difference 4 plus 1 plus 4n minus 8, okay? Now if you simplify, this part will be what? Will be 2n minus 4. This part is what? If we divide, let me write 2n minus 4. If we divide both numerator and denominator by 2, it will be what? It will be n 12 over 4 is 12 over 2. We divide by 2 both numerator and denominator. 12 over 2 is 6 plus 1 plus 4n minus 8. Okay. Now, if you factor from 1/2, we can multiply these two here. So let's see, it will be what? It will be n minus 2 times n minus 6 plus 2 plus 4n minus 8. So it will be what? It will be n squared, n minus 2 times n minus 6 plus 2 minus 4 plus 4 times n minus 2. So here we can reach n minus 2. N minus 4 plus 4 is n squared. So n here is what? For example, here is 6. So let's check. It was 16 plus 4 is 20. But if we check 6 minus 2, 4. 4 times 6, 24. What's the problem here? It is 16 plus. So 16, is it 16 for n6? 4 times 6, 24 minus 8, 16. Yes. Next one should be 4. So if n is 6, 2 times 6, 12. 12 minus 8 is 4. So 16. Y here is not 20. So 4 plus 8 to 2n minus 8. First one. You have 1/2 here. I forgot. Okay. So let's write here 1/2. So it will be this. It will be 1/2 here. So if we calculate it now, it will be what? It will be 1/2 times here. N squared minus 6n plus 8 plus here it's 4 times here, because we factored a common denominator 2, 8 times n minus 2. And if you simplify, it will be 1/2 n squared minus 6n plus 8n plus 2n. 8 minus 16 is minus 8. Okay, so here we've calculated maximum number of green sides or blue sides, as we said. Okay, so the answer we can say is at least n squared minus maximum number of these, which is half n squared plus 2n minus 8. So it will be n squared minus n squared over 2. We can take 1/2. It will be n squared minus 2n plus 8. Okay. Now we prove this. So the only thing that is left is to find an example for even. You can try odd cases on your own. Okay. So let's check this one. Okay. So I think it's good to first try to find an example for n6. That is what? Okay, again, we can consider, for example, this tile here, then this tile here, then here we cannot have this, so we should select this part. And then for here, we can select this one. Again, here we cannot select this or this, so we select this. Again, we select this one, select this. So here we have to select all of them like this, okay? So let's see, does it work or not? So for this case, the answer is at least 36 minus 20, 16. Okay. Now let's see how many ties are there. 1, 2, 3, 4. Answer is at most 4 plus 1, 2, 3, 4, 5. 3 times 5, 15. So this example is an example with 19. Let's see, can we find a better example? If here we try to draw like this part, that one vertical somehow, one horizontal, some vertical. Let's see, for example, if we draw piles like what? Here, for example, we select these two, we select this one, select these two, select this one, we select these two, and then this one, this one, this one, this one. So it will be what? 1, 2, 3, 4, 5, 6, 7. 7 plus how many? 1, 2, 3 times 2, 6. 6 times 2, 12. Again, 19. Okay, so let's check another thing. Here we selected this. Let's erase again these parts. We can select two horizontal, okay? Two horizontal, and then let's try some vertical. This one vertical, this one vertical. This is like this. It is like this. Then here we cannot select. We select like this. Then we select two. We select like this. Okay. Okay. So if we select like this also, what happens here? 1, 2, 3, 4, 5. 5. And here, let's calculate 5 plus 1, 2, 3, 4. 4 by 4, 16 minus 1. 15. This example was 20. Let's see, can we correct it? Try on your own, see, can you reach 16? Here we can erase these things, or let me tell you. Here, we can select vertically also. So for example, here, we can select this one as vertical, horizontal, this one as vertical, and we 1, 2, 3, 4, 5, 6. 6 plus what? Here it is 4 by 4, 16 minus 2, 12. Here is 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. 6 plus 12, 18. So let's see, can we decrease more? Here we can select this one. No, here, not. And okay. Okay, here let's do something. Here, let's select. Let me erase this. Let's select this one. And here it was example that we said. You can say this, or let's say this part. Then we can select here, 2, here, 2. Okay. So it will be 1, 2, 3, 4, 5, 6, 7. Plus how many twos are there? 1, 2, 3, 4, 5, 6, 7, 8. Here it's 15. Let's check it again. 1, 2, 3. Oh, here we cannot have like this. Okay, let me correct it. Here we cannot select here because of these two parts. We can select this one. Okay, now it will be okay. So it is what? It is 1, 2, 3, 4, 5, 6. 6 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so for this part we found an example. Answer is at least 16 and most 16. Now for understanding the general case, let's see 8 by 8. Okay, let's consider an 8. If we replace in our formula here, answer is at least 1/2 times 64 n squared minus 2a minus 16 plus 8. So it's minus 8. 64 minus 8 is 56. So answer is at least 28. Okay. For example, for 6 it was what? 36 minus 12, 24 plus 8, 32 over 216 here. 64 minus 16 plus 8, 64 minus 8, 56 over 2, 28. So let's see, can we find an example? Let's see, can we generalize it? So we select this one, this one, this one, this one, this one, and here, instead of here, we select this and we select this one. Okay, then we select this one and like this. Okay, and the others are like this. Okay, so it will be what? 1, 2, 3, 4, 5, 1, 2, 3, 4, 4 horizontal, 4 vertical, 8 plus. How many ones? 1, 2, 3, 4, 5, 6, 6, 6, 12 plus 2, 4, 6, 8. It's 28 and we proved. Okay, let's consider for general n like this table that n is even. Okay, here again we consider this horizontal, then this vertical, this vertical, this one, this one, this one, this one, this one, and at the end we consider this one. Here we select this, we select this, we select this one, this one, this one. Okay, so let's see how many tiles are there. 1, 2, 2 on. How many horizontal? We know the size is n. 1, 2, 3, 4, 5, 2, n minus 1, n. It is n minus 2, n minus 3. So from 3, 3, 5 to n minus 3, we have horizontal with length 2. It is n minus 3 over 2 plus 1. And then 2 because first one and last one. How many vertical? 1, 3, 5. Here it is n minus 1, n minus 2, n minus 3. Plus n minus 3 minus 1 over 2 plus 1 plus 1. Okay, and then all others are units. So it is how many? It is from 2 to n minus 1. So n minus 1 minus 1, n minus 2. For how many columns? 2, 4, to n minus 4. Okay, so it will be n minus 4 over 2. And okay, n minus 4 to 2 will be n minus 4 over 2. This part, how many ones are there? It will be 2 times 2, 4, 6, n minus 2. It will be n minus 2 over 2 plus 1 because of n minus 1. So let's add. If we add all these things, it should be these parts. Okay, let's check it. It will be n over 2, n over 2, n minus, okay, n over 2 here. Let's simplify as much as we can. So here n over 2, n over 2, let's find coefficient of n over 2 plus 1 over 2 plus 1 plus 1 over 2 plus 2, 2 plus 1. Okay? Sorry. This part that I said n minus 4 over 2, we should multiply it. By what? Because all of them like this. So it will be what? From 2 to n minus 1. 2 to n minus 1, it will be what? It was n minus 4 over 2. 2 to n minus 1 is n minus 2. Okay, so let's review this again. It was n minus 3 over 2. Let me write with green. Okay, the first one was n minus 3. Here was because of these things. N minus 3 over 2 plus 1. Okay. This part, then plus 2 was for these two things. Then here Okay, so try the rest on your own. Okay, try to simplify and calculate number of tiles first on your own. Do the same answer. Okay, okay, two vertical legs. These like this. Then n minus 3 minus 1 over 2 was because of these verticals. N minus 3 minus 1 over 2 plus 1. Plus this one was for what? Because of this one. Okay. Then n minus 2. N minus 2 was for what? And here we should multiply these things, not adding. Here we should add. Here in each of them, 2 to n minus 1 is n minus 2. How many of these columns are there from n minus 1, 4 to 2, n minus 4 over 2? Okay, so all these things we've considered this one, this one, this one, this one. These cells are left 2 to n minus 2, n minus 2 over 2 plus 1 times 2 is n minus 2 minus 2. Okay, so also we have plus 1. Okay, so if we consider, we can say 2 times n minus 2 over 2 plus 1. It is 2 to n minus 2. We don't need to add plus 1 because 2 to n minus 2 is n minus 2 over 2, and plus 1 is because of this. Okay, now let's simplify these terms. So, coefficient of n squared is what? Only here, n times n 1 half. Plus coefficient of n is what? 1 half plus 1 half is 1, plus here coefficient of n times minus 4 over 2 is negative 2. Negative 2 times n over 2 it's negative 1. 2 times this is plus 1. Okay, so it will be 1 negative 2 1 1 is negative n. Okay, it's good because coefficient of n is negative 1, coefficient of n squared is 1 half. Until this part is okay, let's consider constant. Here, minus 3 over 2 is minus 3, plus 1 plus 2 plus 3, minus 3 minus 1 minus 4 over 2 minus 2, plus 1 plus 1 plus 2, minus 2 times minus 4 plus 8 over 2 is 4, negative 2 over 2 is negative 1, 2 times this is negative 2, 2 times this is plus 2. Okay, so if we simplify 2, negative 2 will be cancelled, 2, negative 2, 3, negative 3 is 4. So if we factor from 1/2, it is n squared minus. It is minus, look here, it was minus 1. Okay, minus 1 times n is negative n, because common denominator 2. Negative 2n and plus 4 times 2 because of common denominator 2, 8. N squared minus 2n plus 8. Okay, so here by this example, we proved answer is less than or equal 1/2 n squared minus 2n plus 8. And also by proof, we prove it is n squared minus 2n plus 8, so it is equal. Now, try how many homeworks did we have? So, let me mention it as homework 1. That try to consider when n is odd, try to find the answer like this. Homework 2, we have similar problems like this. Let's see how many ideas did we consider for this problem. This one, this one, this. Okay. Idea 3, considering groups. And we said this. Okay. So, here let me tell you what I did. For this one, I4 is easy. When you have arithmetic progression, when you want to find number of them, it's an minus a1 over common difference plus 1. Okay. So, 4 ideas. Let me tell you some similar homeworks. Homework 2, USEMO 2023, problem number 3. You can do this as homework 2. Homework 3. For homework 3 and homework 4, you can solve these two IMO problems. Homework 5. Question number 5 of USEMO 2023. For homework 6, you can solve this IMO problem. Okay. For homework 7, you can solve this PMO2 2023, last PMO British Mathematical Olympiad. These two Olympiads, PMO and USEMO, are the most two prestigious math Olympiad exam. So try to work at least 7 homeworks, and also we worked on 4 ideas, so 7 homeworks and 4 ideas. Okay, there are around 40-50 important ideas in each topic. If you want to learn them, feel free. If you want to learn more ideas, if you want to know the homeworks or solve more homework, or want to prepare for any math exam, feel free to send message my WhatsApp number in the description and comments. Okay, thanks for watching this video. Bye.